Today, I'm here with my good friend, John Graves. And one of the best things about working in the field of data science is that you get to talk with such smart and interesting people. And John definitely fits that category. So one thing I really appreciate about John is that he's such a smart and intelligent person, but always so willing to share all of his experience and knowledge. Now, just to give you a little bit more background about John, his little bio that I'm just going to read out here so that to make sure that we get everything. So John holds a PhD degree in computer science from AUT University and is the graduate of Singularity University in Mountain View, California. He's worked for high-profile financial organizations such as Morgan Stanley in New York City and Allianz Global Investor in San Diego. He's founded several startup companies in the US and New Zealand. John regularly speaks at meetups and conferences on topics related to artificial intelligence. If you're new to this channel and you're keen to learn the latest tips, tricks, and tools for working more effectively with data, please hit the subscribe button for weekly videos. Really great to have you here today. I think you are going to be able to add a ton of value to the people watching this. So could you actually tell us a little bit more about yourself and how you actually first got into data science?
Yeah, sure. I was doing data science before it had that name. I was working as a quantitative investment manager, or what we call a quant, on Wall Street. We used a statistical package, a SAS, to find patterns in the price and valuation of company stocks, and would use those insights to buy and sell the stocks in a way that managed the overall risk and return of the portfolios. So I'd earned an MBA, and I taught myself to code mostly from books, since I was learning at a time when Stack Overflow, which is an online question and answer site for programmers, was just getting started. My first job as a quant was to make sure that the systematic investment process, managing about a $2 billion portfolio, didn't crash and burn on the 1st of January in the year 2000. So I was hired over 2 decades ago now to fix that Y2K bug wherever it occurred in thousands of lines of SAS code.
Nice. And so having a PhD degree and having done several nano degrees, actually. So I understand you have 4 different nano degrees in different fields related to data science. What would you say is the kind of key difference between what you see in academia versus what you do in industry on a data science job?
So yes, my PhD is in computer science, and the 4 nano degrees are in AI, deep learning, deep reinforcement learning, and digital marketing. So I realized that after getting a PhD in 2013 that my skills were going to become obsolete if I didn't kind of embark on this continuing education. And so these nano degrees have come along and made that much easier, doing the online learning. Basically, academic studies, it's helpful for giving you an appreciation of the theory behind the tools you use in the practice of data science. What you do kind of on the job as a working data scientist is like flying an airplane. If you go for pilot training, you're going to learn about lift and drag, how to make a flight plan, how to communicate with a control tower. And then when you fly the plane, it's how you manipulate the controls and what you say on the radio that it's what matters. And the same idea applies to data science. The controls are the software tools that you have at your disposal, and the presentations and visualizations you create, it's like your radio. So communicating your results is really quite an important part of the whole analytics process.
Right. And I'm just going to check in a extra little bonus question in here. So if somebody hasn't gone off and say done a PhD and say 4 nano degrees or something like that, because obviously you've committed a huge amount of time and dedication to studying these fields and topics, do you really feel like they would be missing a lot, or do you think they would even be able to get into the field of data science?
Well, like I said, I myself was effectively a self-taught data scientist at a time when you had to kind of piece the knowledge together by picking up one book about doing computer coding, and then maybe doing another study of the statistics involved, some of which had been part of my MBA program. Today, the tools are remarkably easier to use than they once were. And so the learning curve is still pretty steep, and there are more than one of them, let me put it that way. So you need to be prepared to be learning about a variety of things, and then kind of bringing all of that knowledge together to make yourself into a data scientist. But it's the kind of thing, if you put a solid 6 months into nothing but learning, you can go to zero to hero in a remarkably short period of time.
There's some really interesting points there, actually. Like you mentioned, I think that computing and technology has changed so much. I mean, you've got languages like R and Python, which in the greater scheme of things are actually really, really friendly. I mean, you look back in the days where we had things like C++, and the amount of overhead and everything that you had to do to make those languages work are just really not that friendly at all. But on the flip side of things, we have a lot more different technologies that need to work together. So I know we've talked about all of the different tools that we use in data science. It's not just, say, R and Python. It's all these supporting tools as well, and these different skills that you need to put together to really become productive. And I know you did a recent talk about this at Auckland University. So do you want to maybe talk a little bit about some of those different tools and that presentation that you gave?
Yeah, sure. So my talk was framed as an addition to what I considered an excellent blog post about this sort of main question of data science productivity by a guy named Owen Flanagan, who also spoke at the same conference. Now, Owen pointed to tools like SQL, the structured query language, command line tools, spreadsheets, text editors, using regular expressions, and suggested data scientists can be a lot more productive if they hone their skills with those tools, along with knowing how to do research, how to write, and actually create tests for their code. So I took all of his thoughts and one step further, suggesting we could use some of these tools of data scientists to gain insights into our own performance and productivity as data scientists, what I call metacognition, or thinking about the way we think and do our work. Now, some of the simple things to consider in this area are keeping a journal of your activity, so you can see when did you start and finish, and so how long did it take for you to do certain things, or using a simple thing called a keyboard macro recorder to speed up your interaction with the computer around routine tasks, and taking the idea of the sort of continual improvement of one's own skill very seriously. The field is changing so fast that the key skill is to have this ability and take the initiative to keep learning.
Yeah, no, absolutely. I think that's one of the things, if you're interested in this field, is to actually really want to have that desire to keep on learning, because all the stuff that's sort of relevant today is going to change tomorrow. I mean, it's shocking sometimes how often I go away and find out, oh, there's a newer, better, faster way to do this and that. And actually, it brings me to another question, actually, is what are your thoughts on like new technologies coming in all the time, and how do you know when you should jump on board and learn a new technology because it's the new latest and greatest thing, and when you should just wait a little while because it's not that refined yet and not really that easy to use or implement?
So again, new technology does come along all the time, and it's always been my practice to take a look at it when it comes out, just to see if is it going to be something that's sort of game changing and it gives us some capability that we simply never had before. Is it something that's simple to integrate into your current workflow or process, or does it require sort of rebuilding everything? And And so there are quite a number of considerations that come into play there. If it's working, don't fix it. Is one kind of conservative rule of thumb. So you do have to be a little bit conservative sometimes, and realize that it's not the end of the world if you're using something that is ultimately kind of a legacy code or tools. They will eventually be made obsolete. But so long as you've got that radar out there looking for what's coming on the horizon, and again that willingness to learn and adapt to the changing systems, you'll be all set.
Yeah, no, absolutely. I guess these days, when different technologies like Hadoop and TensorFlow came out, I mean, they obviously received a lot of press. There are conferences around them, new, latest, greatest, most wonderful thing. But I think that at the same time, I think people appreciate that when they first came out, they were really, really difficult to use. Like, I mean, when Hadoop came out, you really, really had to have strong software development skills in Java and all this kind of stuff like that. It wasn't built for data scientists and analysts as such. And it hasn't been until sort of the very kind of new iterations of things where you are effectively using SQL on top of it, using stuff like AWS Athena and those kind of things, which means, if you've got a little bit of experience in databases, then all of a sudden, wow, now you can drive Hadoop without having to become like a full software engineer. Right. So, I think there's definitely a kind of it's really good to be aware, but there's I think a right time to jump on technology. And I think you've made some really good points as well. So I guess the next question then is that, these days we have a lot of coverage about data science and AI and everything in the media. And, what would you say, or would you say there's any kind of common misconceptions you think that people get from all this coverage that we're getting at the moment?
Yeah, absolutely. We've entered what's called the augmented age now. Artificial intelligence, it's not bringing the Terminator to kill or replace us. It's instead our minds are getting that sort of same kind of power boost that our bodies got during the industrial age. So basically, whatever kind of thinking or creating we've been able to do in the past, we're just going to be able to do more of it and better. So I'm a real techno optimist.
Yeah, no, absolutely. The technology is really pretty incredible. It's very, very exciting. I think with a lot of the new technology that we have now with deep learning and everything like that, it basically enables us to automate a whole bunch of things that we couldn't automate before, right? Because stuff used to be, I don't know if the right word for it, but almost like a little bit too digital or something, right? I mean, or too kind of binary is maybe a better way of putting it. So, I think that the technology. I mean, actually, the technology is already incredible. Probably one of the key things limiting it, if anything, I think, is actually the quality and the quality of data which has been sufficiently categorized and labeled and everything like that. I think is probably one of the biggest obstacles to actually getting a lot of projects done. So,
there's certainly a lot of data out there. Every time you make a phone call, send a text message, click on a website, the Internet of Things is coming along. You're using your apps to buy your food, order your Uber. I even manage my electricity supply through an app. So you're going to find that there's data these days about just about everything in the world, and all of that data needs some kind of analysis, and hence the demand, an increasing demand for data scientists.
Yeah, no, it is pretty incredible. As you mentioned, with the number of devices that we have today, IoT devices, just the logging that we have on our different systems, because everything is digital, there is this huge trail of already pre-digitized information, and I think that's really key. And I think being like, if you are an organization or something, being really strategic about the actual information that you're collecting through these different sources and how they can be joined together and all those kind of things, can really make the difference to whether you're able to capitalize on those data assets or not.
Agreed.
So, what would be your best advice for somebody who is wanting to get into the field of data science?
Right. Data science, well, it can be a really super rewarding career choice, but I'd say only go for it if you kind of enjoy this constant challenge of unsolved puzzles. Like, do you like Sudoku? Or if not, then maybe try a slightly different role like a business analyst. And once you kind of like working with data to generate insights, spreadsheets are definitely like the quickest and easiest way to start. And you work with some data that you personally care about, like your own expenses. How much of your income goes to your rent or your groceries or to entertainment. If you're already working with business data using tools like Excel, it's time to begin learning about writing some computer code, because that's the way we automate sort of more of the analytic process. They're replacing those many manual steps required by a spreadsheet with a script of actions that we can simply run. Now, if you're coming from a technical side, such as a software developer, and you already have computing or coding skills, you need to pick up an understanding of like basic statistics. Keep in mind that data science is this sort of sweet spot where the coding, statistics, and business knowledge all overlap, and that's why the jobs pay so well. You need to have this combination of skills to be successful.
Yeah, no, no, absolutely. I mean, as you mentioned, it is this kind of sweet spot. And I would see like a lot of people coming in from all of these different angles. And there's always so much to learn, I find, from like all of these different fields. Like, as you mentioned, a software engineer, they have a ton of skills to building better solutions, since the solutions that we develop are effectively a type of piece of software. And so there's really good practices around that, like unit testing, continuous integration, and all of these practices that software developers know very well, but maybe an analyst or a statistician doesn't know those things, right? And so there's a real value in being able to learn, or at the very least appreciate some of those skills, because that's going to help you become better at your task, or at least managing your teams, to kind of push them in the right direction, because that there's this spectrum of skills, and as you progress and as the complexity of the solutions progress, you really need a way to effectively manage that complexity before it kind of gets out of control, right? So Excel spreadsheets, fantastic for a sort of certain use case and for a period of time. But when you start building those out into like really complicated solutions, then actually maybe at least consider that there might be some better solutions for that. So, yeah. Any other advice that you'd like to give to people?
Just keep learning, and I think taking advantage of the Data Pro courses is an ideal way for most sort of aspiring data scientists to get acquainted with some of the terminology, some of the tools, and set you on the road to having a successful data science career.
No, I appreciate that, John. So I guess another thing I just wanted to point out as well is that, like as mentioned, there really is a wide spectrum of skills. And one of the last things that I want to do is kind of scare people off by things being overly technical. So, for a long time, I was actually working with a lot of Excel and everything myself before I kind of made that transition into R, and then having those tool sets and then being around that community and having a tool where people were using and applying different techniques enabled me to start applying some of those as well. And that's one of the things that really helped me a lot. But then after kind of being involved with the community and getting to know people like yourself and talking with friends and finding out how other people are doing things and the best practice that people are using, you really see like how far you can actually go. So, I mean, you can start at any of these kind of sort of different points, but it's really nice to be able to look to the people in the field who are like really, really good at that stuff and kind of aspire to be like that, or aspire for your team to be like that, and again, just an appreciation of the different skills that are available. Now, another thing is, I understand you also do some teaching as well. So one of the things I really appreciate is that, like I mentioned, even though you are so technical, you do take the time and you teach courses and classes to non-technical individuals as well who are looking to understand more about the field. What would you say are some of the kind of key lessons that you teach to them?
So the introduction to data science courses that I've been involved with really take people through all of these buzzwords that people have been throwing around, and no one has bothered to actually clearly define. What is big data? Why do we use algorithms? How do the capabilities of cloud computing and the pace at which the whole world is being digitized relate to our ability to make business decisions, because in some cases that connection isn't obvious, and it really does help to have somebody who's been through the process to lay it all out and show how you get from raw data all the way up. It's kind of a hierarchy of process data, insight, information, and then ultimately this artificial intelligence is kind of at the top of the pyramid.
Right. Cool. And I mean, would you mind sharing like some of your definitions of like big data and those kind of things?
Well, a simple definition for big data is if it can't fit on your laptop anymore or in your spreadsheet anymore. Yeah. So quite a lot of businesses, of course, have grown to the point where there are terabytes of data about the customer base, and the only way you're going to process that is through tools that involve working with a database rather than just a spreadsheet.
Yep. No, that's that's really handy, I think. I mean, one of the things I tell people about big data is basically it's too big when you can't process it on a single computer. I think one thing that's hard for people to get their heads around sometimes is that if you are coming from a background where you're using Excel and the thing starts to crash after 40,000 records or so, that's probably not quite the realms of big data just yet, because another thing I find is that, especially back in the day, people would be jumping onto Hadoop when, like the Excel spreadsheet was too slow. And there's a lot of intermediary kind of tools in there as well, where, when you're using something like R or Python, you could be processing millions of records of data on a laptop before having to move to multiple computers, which is kind of the world of big data.
Yeah, there definitely is a continuum, and so one of the key skills in terms of working practically as a data scientist is fitting the tool to the task and making sure that you aren't killing a fly with a bazooka.
Yeah, no, absolutely, and I think that's it's great to gain an awareness of all the different tools available. And I mean, that doesn't necessarily mean that you have to learn or master every single one of them. I mean, I know that you're familiar with like dozens and dozens of tools, but I'm sure there's a handful of them that you use in your tool everyday kind of toolkit to use. And I guess you just know that if the situation arose, that you could actually dive in and use some of these other technologies because you know that they exist. But that doesn't mean that you necessarily have experience in them now. I mean, I don't know if you feel the same way, but that's definitely been my kind of experience of things.
Yep. Yeah, it's sort of like you've got a quiver of arrows, and most of the time you're shooting the same arrow at the same target, but occasionally there's a different target, and it's good to have a different arrow for that one.
Yeah, no, absolutely. Because I was just reading something the other day, and it was talking about how people these days they're concerned about having to learn too many things, basically, right? Like, oh, should I learn R or should I learn Python? And I mean, I know you've used both languages yourself, and
yes, and many others,
and many others. So I know from my own personal experience. I mean, this might sound like a little strange to some people listening, but pretty much all the programming languages that I know, I didn't actually learn them until after I started a job, not before. Because a task pops up and it's like, oh, you need to do some web development, so then you learn some sort of web development language, and then it's like, oh, you're an organization, and the only thing available is Excel. It's like, oh, so you learn some VBA, right? Or it's like, oh, we have R or Python or something like that here. It's like, oh, okay, cool. I've got a nice scripting tool all of a sudden where you can start to do an analysis, and then you learn that tool as well. And so, I think learning the tools that you have available to actually use means that you can actually start to apply them straight away and practice them straight away, because otherwise, you are kind of learning them a little bit theoretically. And I don't know what kind of your feeling and thoughts on that are.
So yeah, it always helps to have an actual application for whatever you're learning, and to work through examples rather than just study it in the abstract. So again, going back to my do something with your own personal finances if you haven't ever done any kind of analytics, just so you can get a sense of, all right, every time you start working with a new computer language, you could try to do the same analysis that you did with the prior tool, and because there are differences between computer languages, but at some level they're all trying to do very much the same thing, which is communicate our human intent to the machine so that it can execute our intent. And they're going to use very similar concepts from one language to the next. The syntax of the code is going to be different. The format of it, the way it looks on the page is going to be different, and the ease with which you kind of can work with it is likely to be different. But for the most part, the objective could be identical, and you could again pick the language or the tool that's most appropriate to what it is you're trying to do.
Yeah, no, absolutely. I mean, I think that, at the end of the day, there's a lot of programming concepts. They're all kind of the same, but certain languages are just far more elegant and just friendlier for implementing certain things. So instead of necessarily thinking about learning a different programming language because you've got a new task that popped up, take a look at it and go, wow, in this language here, I can express this kind of problem, the type of problem that I'm doing every day or doing very frequently, or at least facing right now. And I could express this in, say, 5 lines of code, and have it run, say, 1,000 times faster with like all of this error checking and, like all these things kind of built into the language because that's what it was built for, as opposed to Maybe there's other programming language over here, which maybe you're familiar with, but actually that's 100 lines of code and it's like less robust and it's more slow and, like all these different things. So sometimes actually learning a new programming language for the type of thing that you can, that you're trying to do can actually be a lot easier. And so it's just about, this kind of goes back to your whole piece about being productive as a data scientist is, well, there are all of these different tools that you need to learn, but actually for certain things, they're very useful. Now, there can be some difficulty in that sometimes. There can be some learning curve because, all of a sudden you're maybe using a completely different environment. You're not using your standard tools or your standard IDE and all these things. So on top of having to learn a new programming language, there's all these like fiddly little bits where you're not quite sure where to click. You're not quite sure where to look for different issues. And that can be a little bit frustrating as well. And so that's why, I wanted to, we started talking about putting together some sort of exercise or program that would go through a lot of these types of things through a practical example that people could work through. I mean, this is effectively how I learned our programming. I sat down with a friend. He told me all the stupid things that I was doing, and how I would translate my knowledge from, say, before that I was using say Excel, VBA macros and stuff like that, and translating that into something like R, and through practical examples that I would do in sort of Excel VBA, he'd show me how to do it in R instead, and that really got me started, and that kind of led on to everything else. And that's, I wouldn't be here today if it wasn't for that start. And so we've talked about putting together a bit of an example and program which would kind of illustrate that for really this technology stack, because as mentioned, Python is incredibly popular programming language these days, but then you've got Bash, you've got SQL, you've got Git, you've got Docker, you've got like all of these different components, and it can really be pretty overwhelming, right? But out of all of these different things, maybe there's only a small slice of it that you need to do. Like, for instance, if you're learning SQL, if you're a data scientist, a lot of times you're not building a database application to collect, to read and write data. A lot of times it's read only. You're just extracting it, gluing it together, those types of things, right? So if you took all of these technologies and compacted it down to the pieces that were relevant, and you kind of strung them all together, you could see how they fit all together, and you could spend a lot less time learning it than, if you tried to learn every single one on their own.
Yeah, I'd say the thing that has made data science capabilities more than accessible than anything else is the idea of a cloud-based Jupyter notebook. And this is an environment where literally, if you just have a web browser, you can go to these websites. Google has them, Amazon has them, Microsoft has them, IBM has them, where you can open up these notebooks and do your coding. You don't have to install anything on your system. All you need to do is provide or find some online data, and then you can do your analysis just right there in your web browser, and you can learn how the whole system works and have your entire focus be on the code that you're writing, the analytics kind of questions that you're trying to answer, and the visualizations that you want to create. And it all happens just right there in your web browser. And that kind of capability is just, it's game changing, because it democratizes the whole process. We don't have to be when I started, you had to go to a computing center and book the time that you were going to have on the mainframe. And today it's anybody that has the right web link can get onto a Google Colab Jupyter notebook and start coding in. The reason it's called Jupyter, it's serves either to code in Julia, Python, or R. So all of those kernels are available to you just from the get-go. Give it a try.
Nice. So yeah, anyway, lots of little recommendations there for people to go out and give things a go. For anybody who would be interested in getting a little bit more guidance for these kind of things, having someone like John and myself walk through certain examples using all these different technologies, using and working through some sort of project, then there'll be some links in the description below that you can go and click on if you want to check them out.
Really excited to be helpful.
Awesome. So yeah, thanks so much for your time, John, and we'll catch up again soon.
All right, cheers.